Hello and welcome to another Azure Developers Live. I'm your host for today, John Galloway. I'm filling in for James. Very excited to be here. We got a lot of great stuff for you today. I'm going to just get started with the links for today. So we've got a lot of great stuff. I'm sharing them in the chat and they're in the description. So let's just go through these. First of all, we've got, this is great. We have GA for Azure Container Apps serverless GPUs. So if you've been doing anything with GPUs, especially nowadays with AI workloads, et cetera, you're going to need GPUs. So now with GA, there's a lot of great stuff available. So first of all, there's scale to zero, which is huge. So any kind of workload that can scale to zero means you're paying less. When you're not using it, scales down to zero, charges you zero. That is wonderful. Per second billing. The other Azure value adds you get for all the services like built-in data governance and things like that. So it talks about the different scenarios, real-time batch inferencing, etc. So I am super, super excited to see this. I'm glad to see quota available for GA, etc. So this is right when this ends. I'm going to be going and turning this on for some of my workloads. Okay, Azure at KubeCon. So April 1st through 4th, the Azure folks are going to be at KubeCon. So there's an Azure Day at KubeCon on April 1st. They're hopefully going to be avoiding any April Fool's jokes on you and all kinds of great stuff, choose your own adventure, etc. And then throughout the rest of KubeCon, there's and Cloud Native Con, there's going to be booth and sponsored keynote, etc. So great stuff there. All right. AI-powered load testing in VS Code and Azure load testing and GitHub Copilot. So the deal here is that load testing is something you should be doing, and generally in the past, you have to create scripts, maybe in languages you don't understand or things you're not as familiar with. But what you are probably familiar with is VS Code and some of the different things you can use there, like HTTP files, etc. So what's great here is you can go in, you can take your existing like HTTP files, Postman collection, Insomnia collection, etc., and then you can create those Locust scripts or like feed those into load testing. So you can also refine them with like AI-powered customization, etc., random payload workloads, etc. So this is something where like I was saying in the past, whenever I'm needing to do this, I feel like it's a whole new thing I need to learn. This is amazing to be able to translate that for me and then get all the Azure load testing goodness. So really cool stuff there. All right. Azure Platform Metrics for AKS, control plane monitoring. So the deal here is that in the past, this was only available for paid Azure managed Prometheus, which I don't have. Maybe you had. I didn't have it. This is cool. This is now automatically collected and free for all AKS clusters. So this is a really cool feature. This is available now. You can just go ahead and turn it on. So it shows you how to do that and the kinds of things you're collecting there. All right. App Service Auto Heal. So some neat things here. One is that you can just turn it on, and two is that you can capture, like the black box feature, you can capture things when things do crash. So first of all, like it can do things like automatically recycle the application process and then collect those dumps for you. So this post shows you how to turn it on. So I'll scroll down to there. So you diagnose and solve problems. You go into there and you say, turn on auto heal. And then you can also say afterwards that you want to collect profiler, thread stacks, etc. So this is awesome. This is really cool. All right. We have two great things here for generative AI. So we have the course Chris Noring wrote up and is announcing here on JavaScript. So it's a whole course on generative AI. And then we also have a .NET version of this. So I've gone through this, some great stuff in here. One of the cool features here is there's a bunch of 5 to 10 minute videos for each concept. So these are things where like on your lunch break or coffee break or while your code is compiling or your app is deploying or whatever, you can go and watch a short video and learn a thing. So as an example, this shows you great stuff about how to add in things like semantic search, right? So this is something I would like to be able to add in my app. I don't have time to learn all the stuff about semantic search. So this is not doing like an exact match. This is saying like, what should I wear in cold weather? And it figures out things like, oh, you probably want a jacket, right? There's also real-time voice search, etc. All kinds of great stuff there. So this is really cool to be able to go through. And again, this is available for both JavaScript and .NET. And now this is, I'm not going to spoil all the excitement here because Nick's going to be coming on in just a second and sharing all the information here. But there's also a great blog post. So the blog post explaining about the durable task scheduler, explaining all the benefits. Like I said, I'm just going to go ahead and I'm going to bring Nick on. And welcome, Nick.
Hi, John. Thanks for having me.
Awesome. Yeah. So so durable task scheduler, and I guess I will go ahead. I'll add your slides on. I'll disappear and I'll let you take it away.
Cool. Yeah, so my name is Nick Greenfield. I'm a product manager on the Azure Functions team, and I specifically focus on the durable functions feature. And that's exactly what I'm here to talk to you about today. I want to introduce a new feature of durable functions called the durable task scheduler. But before we dive into the durable task scheduler and its features, I just want to provide a couple minutes or go through a couple minutes providing some context on Durable functions, for those who might not be aware of what it is, when you would use it, how it works, that context is really important when then we talk about the durable task scheduler. And I'll even show some demos of it in action. So let's get right into it. We'll start pretty high level. We'll go through like what is the overview of durable functions, and then again, this will start to make more sense as we look at some code and even the demo. But durable functions is an extension of Azure Functions. So Azure Functions, our serverless compute offering, and durable functions allows developers to author code to chain stateful functions. And that process of stateful functions chaining can be referred to as orchestrations or workflows. For the purpose of this talk, we'll use those interchangeably. But yeah, a workflow orchestration is a series of tasks that must occur in a certain order. They can be long running. And so I have some examples here of some patterns that durable functions support today. So sequential chaining, that's probably the most straightforward, is where you can have one stateful function invoke another. But it also goes beyond just sequential chaining. Durable function supports patterns like parallelization. So we have a pattern called fan out, fan in. And so if you need to chain functions and then do a bunch of processing in parallel, you can fan out. And then once that processing has been completed, those functions can fan back in and it can continue on that workflow orchestration lifecycle. And one more example of an app pattern that durable functions supports today is human interaction. So again, I have a series of tasks or functions that need to occur in a certain order, but they may need some human interaction or some signal for it to to let it know that it can continue. And so a good way to wrap your head around this app pattern is like a customer support ticket, right? If it needs a human approval, someone can go in, raise that event, and then that orchestration or workflow can continue on. And so the real value of durable functions is that it lies within the programming model and the backend component. And that setup allows for that easily implementing this coordination and durability of these function calls, right? And so as a developer, you can just rely on this extension, and you don't have to actually architect your code around that coordination, that chaining, and fault tolerance, meaning if one of those functions was to fail, how do you recover from where it left off, right? And so durable functions is really providing that value, that coordination and journaling of your stateful function calls. For the sake of time, I'm not going to go through all the scenarios that we see durable functions being used. I'll just highlight one of these, and it's probably with this AI buzz that we're going through recently, we're seeing durable functions used in a lot of AI and agentic applications more and more by the day. You can think about any application that requires orchestrating, so whether that's multi-agent applications and you're chaining prompts to those agents, and even RAG. If you think about the RAG process, right, that can be pictured as a whole end-to-end workflow. There's also many scenarios where durable functions is used outside of AI. And yeah, we'll go through some of those in the demo in just a minute. And so this is quite the busy slide, but we'll take it piece by piece. I want to show how durable functions works, like how you as a developer would write code to use durable functions, and then what's actually happening behind the covers or behind the scenes. So on the left-hand side here, I have an orchestration function, right? So this is the function that I have running in my functions compute using the durable extension to author this code. And so this is an order processing scenario. So imagine this is an e-commerce store, an order had just been placed, and that is, in order to fulfill that order, there needs to be a workflow or an orchestration, a series of steps that need to be called in order to complete that scenario, right? And so the first thing is, as you see, this orchestration will get fired, and the framework's going to call the first activity function, the first step, which is verifying the inventory. And this is just another function call that you would implement your business logic. In this case, verifying inventory is probably making an outbound call to some state store to make sure there is enough of that inventory of the item being purchased. The result is deterministic and it's returned back. And then as you can see, the durable functions is going to call the next, and your compute is going to call the next activity for execution, in this case, process payment, passing in the result from that previous activity call. So that's that coordination happening right there in real time. And then I mentioned the other value prop is durability, right? And so each one of these calls is being persisted in this backend component that I mentioned. So what that means is if one of these activities or orchestrations as a whole was to fail for whatever reason, a downstream dependency goes offline, a transient error, you don't need to restart your orchestration from the beginning. That can be really problematic in a lot of scenarios. If you think about it, right? You don't want to, in this case, update inventory twice or charge a customer twice when their first order wasn't successful, right? So since each one of these calls is being persisted in the durable functions backend, it can just resume from where it left off once things are able to recover. Right. So again, this is the code that you would be writing, deploying to your functions compute. And on the right-hand side here, this is kind of like, this is what's happening behind the scenes. So you have this code running in your compute, and then there's that backend. And that's what, like, we describe this as like the brain of durable functions. It's where a lot of the heavy lifting is happening. In this case, it's the backend that's telling your compute, okay, schedule this first orchestration, schedule the first step. If that's successful, persist that state in the backend, and then tell your compute, run the next step, right? It's able to handle retries because it has that state being persisted. And it's able to load balance all of these orchestrations across your various compute instances, right? So it can really make sure it can handle scale, especially if those large volumes of events come in that schedule orchestrations. Durable functions can, scale across your different compute instances to make sure you can, handle that load effectively. And so there's 3 backends that are available today in durable functions. There's the Azure Storage, Netherite, and MS SQL. And these backends, depending on the developer or business scenario that's trying to be fulfilled, you would choose, they offer different capabilities, so you choose one of these. They're self-managed, meaning you have to go off and provision and manage those backends over time on your own. And we'll get more into that in just a minute as well. So this is how durable functions works. This exists today. Durable functions has been out for, I believe, like 7 years now, and there's a lot of great usage. We engage with our customers regularly, and we're always looking to improve our products and offerings. And so over the years, we've just been keeping an eye on any areas that we can improve, any opportunities and gaps that we can fulfill and for our customers. And so these are some of the themes that we've captured throughout the years around areas of improvement, and which is going to lead into the motivation of why we've invested in this durable task scheduler. And so to go through these, some of the things that we've heard from customers is the bring your own storage backend. So those 3 existing backends that we have today, as I mentioned, they're self-managed, which provides a lot of operational complexity. You have to manage the state that's being persisted of all of your orchestrations in that backend, and that can affect the performance over time. And so that's a lot of operational overhead that development teams just don't want to have to deal with. Versioning, so versioning orchestrations. If you have to release new versions of an orchestration that maybe there's ongoing orchestrations from the previous version are still in flight, how do you manage these new versions when there's old versions still in flight without any downtime? So the versioning story is very difficult. Observability, so these backends are just storage accounts. So meaning if you need to go in and understand, why is an orchestration taking so long, or why is it stuck, you have to go through these storage logs and kind of do that correlation yourself. It's really a challenging process. Performance isn't sufficient for all use cases. So these, as I mentioned, there's some scenarios where bursting of events will schedule many orchestrations that need to be processed as quick as possible. And the 3 backends that we've heard, just some of them are not up to the standard that some customers need. And then lastly, strong ties to functions. So this it is what it is. Like durable functions is available in functions, but we also have some developers who want to use the durable functions value prop, but they have other requirements that require them in other compute offerings. So not functions, whether that's ACA, AKS, or even app service. And so it's with all of those things in mind that our team brainstormed and how can we address and improve on those. And so we learned and discovered that we can actually improve on all of those things with introducing a new managed backend to durable functions. So we have those 3 existing ones. This would be the 4th, and unlike the 3 existing, this is a fully managed offering by Azure, by us. And so just to look at the offering here, the value props of the durable task scheduler, it has native integration into not only durable functions and all of the programming languages that durable functions supports, but we're also introducing this new client-only SDK that can be used from any compute outside of functions. And I'll show what that landscape looks like in the next slide. It's the most performant backend. It's, as I mentioned, it's a fully managed backend. It's the state store that's built in is the most performant out of the 3 existing ones. So it should really meet those high demands for high performance and scale. It's got built-in monitoring and management. So there's a dashboard, a UI dashboard that you can log into and see the whole life cycle of all of your workflows, and you can click into them and see each step that's been called, how long they took, and so it makes debugging and tracking your orchestrations very trivial. And then lastly, it can be leveraged from any compute offering. And in fact, today is the announcement of Durable Functions supporting the Durable Task Scheduler as a public preview. So you can actually go and create a function app, author your durable functions, and leverage the Durable Task Scheduler as your backend in a public preview status. You can just go off in the portal, CLI, Bicep, whatever your mechanism is of choice. You can leverage DTS. And then, as I mentioned, the other compute offerings are also, you're able to leverage the Durable Task Scheduler as well through this standalone SDK. So really, this would be the orchestration framework of choice, depending on where you deploy your workloads. If you're in Functions, you're using Durable Functions. If you're in any of these other compute offerings, you would use the standalone SDK. It's very much just a client SDK that connects directly to this managed backend. Hence, that's why, hence the portability. And that's where this managed workflow engine is running, and that's where that built-in state persistence is for your orchestration. So it allows you to just leverage this from any of these Azure computes that we have today. So that's an overview of Durable Functions and the Durable Task Scheduler. And I thought, why not show a demo of this in action? I think that's what everyone is interested in seeing. So I put together, and I'll zoom in on this in just a minute, but this is the scenario that I put together a demo for. It's a intelligent PDF summarizer. So the idea is that you can take PDFs from the web, any PDFs, you can drop them into a storage account. It's going to trigger a durable function, and it's going to intelligently analyze this PDF by making calls to some of our intelligent services. And so if we look here, this is the PDFs dropped into a storage account. And if we look at this code, this is my orchestration function. Hopefully that's big enough for everyone to see. I have an orchestration function called process document. This is triggered on every blob upload of that PDF. First thing I do is I set some resiliency policies, retries, for example, and then I have this analyze PDF activity call. So that's that first step within my orchestration. I pass in the PDF name, and what this does is it makes a call to our cognitive service form recognizer. And so what this can do is take that PDF, which can have images, tables, and text, a bunch of stuff in it, and it can translate it to text and return that text from that call. So once I have the text of that PDF, I then make another call passing in that text to my summarize text activity function. This is actually going to call Azure OpenAI using the function's text summarization binding and asking Azure OpenAI, can you summarize what this PDF is about? Here's the text, provide a summary. And I am doing this in 3 different languages. So I wanted to demonstrate the fan out process, right? So this is that multiple processing happening in parallel. So once I have the summaries in those 3 different languages, I'm going to call the last activity, write doc, where I'm going to write those summaries in those languages to a new text file, and then upload them back to a blob storage account, in this case, the output container. And as I mentioned, this code here is all backed by the Durable Task Scheduler. So not only am I going to get that hyper performance, which will be a little bit hard to demo here, but I'm also going to get that monitoring and management dashboard out of the box so I can track and see everything that's happening as it happens. So what I'm going to do now is switch to my Azure portal where I have this entire solution deployed. We have this in our samples. So if you want to try this on yourself, you by yourself and poke around, you definitely can. It's in the Durable Task Scheduler samples repo. But I want to just point out that I have my function app here, I have my Durable Task Scheduler resource here, and I have my intelligent services also deployed. Here's the Durable Task Scheduler. There's such thing as a task hub. These are just logical ways to separate where your orchestrations are being processed within Durable Task Scheduler. So I can have many different apps sharing a Durable Task Scheduler, and they can have different task hubs, which allows me to provide RBAC and privileges. So it's a way for me just to separate all the different apps and all the different users that might be accessing this scheduler resource. So I have this resource set up. And then I have my function app that's been provisioned. And the only thing that I need to do to connect my function app to this durable task backend is provide an environment, an app setting. So in this case, I have an environment variable called DTS connection string, and that's just pointing to this endpoint that I have here from my durable task scheduler. And I'm using managed identity, so there's no we only support identity-based authentication with durable task scheduler. So I have the user assigned identities wired up so that my compute can connect to this backend. And I have the task hub for where this function app will be writing to. It's just a randomly generated GUID here. And so with that, let's run this. So I will go into here and I will upload a PDF. And so I have a PDF here. This is just a random, I found this from another Azure sample. It's a Microsoft tax document. I don't even know if this is real, but it's out in the public. And I'll just take this and I will upload it. We'll hit upload. And what should happen, hopefully if the demo gods are on our side, is that this should be triggering my durable function. It's going to be doing all the intelligent analyzation, and then it should write the output of this into an output container. Let's see. Oh, there we go. So I have French, Japanese, and Spanish. If we open this up, we can download it. Let's just look at it. There you go. I have my summary in Japanese here. So that's cool, but I actually wanted to show the durable task scheduler built-in dashboard. So this is the last part here of this demo. I'm logged in here. I have the right roles that allow me to see this information within this task hub. So this is the dashboard URL that I get from my durable task scheduler. I'm in the context of that single task hub that I had provisioned and have been processing my orchestrations within. And so here I can see right off the bat, I have all of the orchestrations that have been executed. These are some previous runs that I was just testing. But this last one was the one that we just did, and it completed successfully. It tells me exactly how long. I have some filter cards here that I can, if these were long, we have some pagination built in, but I can easily filter into failed with orchestrations that are running, pending, and so on. But the nice thing about this is I can actually dive into these orchestrations and I can see the entire lifecycle right off the bat. So here's the entire trace of the orchestration, how long it took. And then I can actually see each activity call. So here's where you see the analyze call, which is that cognitive service passing in the name of the PDF, and then the output of that call to cognitive service, the text, right? This is the return value. And all this is persisted in our backend here. And then I fanned out and asked Azure OpenAI to do that summarization, right? And so here I should see the return of, hey, summarize this text in Japanese, summarize this in Spanish or French, right? So here's that parallelization and then the writing doc. And lastly, I have these controls here that if I needed to, again, assuming I have the right roles, I can pause, resume, retry, raise an event, that human interaction. I can say, hey, this can continue, like raise an event, send that signal to the control to the orchestration. So I have those management actions here right within this dashboard as well. And the last thing is we surface exceptions. So if you have a failed orchestration and it fails for whatever reason, you can actually go in, look at the activity, and then that exception will be raised right to you. Like, this is the reason why it failed. We surface that back to this dashboard. So it should make troubleshooting and debugging a lot easier as well. So that's it. I do have the slides, back to the slides, just a couple links. As I mentioned, this is in public preview for durable functions today. Today's the announcement. There's an announcement blog post. It goes into a lot more detail of what I've shared today. We have our documentation published as well as many samples that you can try, not only for durable functions, but also that durable task portable. We refer to that SDK as the portable SDK because it can be leveraged from any compute. And we have samples for you to try that. So we'd love for folks to give this a shot. We'd love to hear if there's any feedback. Our line's always open. And that's it. Thanks for having me on today's show.
I'll go ahead and unmute. It works better that way. That was awesome. Hey, I've got a newbie question here.
Yeah.
Maybe you can walk me through. So you were hooking up, you were calling some different services. I love that you can call off to like cognitive service or different things there. That seems awesome. They were by like a string name, right?
Yeah.
So where does that actually get wired up? Like, how does it find that? Is that the name of the service or like, I didn't catch that?
So these I don't know if my screen's still sharing, but
Yeah, it
the
is.
string name of the function, these are actually just other activity functions. So below this I'm looking at this function called process document, right? And I could use name of instead of passing magic strings, but
Okay, that was another
these
question I had. Yep.
yeah, so these are just other functions that would be lived elsewhere in my code, and that's where the business logic would for that specific function would lie. So in this case, the analyze PDF is making a request to the cognitive service. I can't remember exactly how I do that. Maybe just through uh, a normal
Like an
client, like
API call or whatever.
yeah, exactly. And so summarized text though, in this one we're using the Azure Functions AI bindings, and so it's a nice, just really lightweight way to make a call to Azure OpenAI. I have some environment variables that allow me to access that instance of Azure OpenAI. But these are just functions, other functions that live elsewhere in my code, and that's where the business logic really resides for each of these.
Got
Does
it.
that answer your question?
It does. Yep.
Cool.
So we had a few other questions. I'll take us back to this view. Okay, so first of all, a question from Tech Writing. I've heard about Dapper workflows, which is similar to durable functions. Will durable task scheduler work with it too, or is that too different?
As of now, there is no current plans to integrate durable task scheduler with Dapper workflow. I will say maybe not out of the realm of possibility. Dapper, I am also someone that has worked on Dapper in the past. Dapper workflow has pluggable backend workflow components, so it allows you to plug in, the default is the actor system.
Okay.
But you could, in theory, write a component. Maybe someone from the open source would do that. Write a component to support this new durable task scheduler backend. In theory, it could work. It's just not something that we have on the immediate roadmap.
Okay.
Yeah,
All right.
good
Another
question.
question from Tech Writing here. The dashboard looks like the durable function monitor VS Code extension. Durable function monitor is something we could deploy as a standalone service. What are the differences?
Yeah, so this dashboard is heavily inspired by the DFMon dashboard. That is, I believe it's in like an open source project. It's self-managed as well. The idea here is that this dashboard is provided to you built into the durable task scheduler. So as soon as you instantiate this durable task scheduler, you're provided with this dashboard URL right out of the box. And so it's a lot more lightweight, built-in, less setup management, but it's ultimately providing a lot of the same capabilities and features. And we're going to continue building on this dashboard. Like, it's going to support other features in the future. Entities, a whole UI system for entities is coming in the near future, and some other things that you'll find that are not available in the monitor, but will be available in this. The other thing that I want to mention that I forgot to mention is that for local development, we actually have an emulator for the durable task scheduler. So it's just a container that you can pull down, run on your machine. It will provide you with all the durable task scheduler APIs, so you can run your orchestrations locally. Everything's stored in memory, but it also provides you with this dashboard as well out of the box. So just something that I wanted to mention for those that are like, how do I do local development with DTS? Like, we provide a container for you to do that with.
Awesome.
Yep.
Okay, one last kind of good wrap-up question. So Jorge Levy is asking, where can we check the documentation for this feature? So I saw at the end of the blog post, hopefully this is right here.
It should be. I'm actually looking at my screen.
It's a AKMS DTS getting started.
Yeah, that should be fine, and if not, I'll make sure it works.
Awesome.
But yeah, it's in the durable task scheduler docs are live in the Azure Functions durable functions doc area. So if you find durable functions and you look at those other backend providers, you'll see a new introduced durable task scheduler section, and we go into a lot of the stuff that I went through today, but at more length. So it's the performance side of things, the getting started sample, stuff like that. So I do encourage people to look at that. We're limited on time today. We have a lot more information that you can find in the docs.
Awesome. All right.
Cool.
Really
Thanks,
cool. Congrats on the launch.
Thank you.
And great presentation.
Thanks for having me.
All right. So now we are ready for what I refer to as the app service party. So we've got a bunch of people. We've got Byron, we have Denver, and we have Jeff. So great. Okay. So I guess my thing here is to say, take it away. Whose screen are we sharing first?
Let's start with me. And yeah, so seems like we scheduled this all in a great day, because we have also like a bunch of like day zero announcements, things that are rolling out right now. So what we're seeing right now is this is the app service blog. I think I gave you the URL for it, John, if you want to throw it on the screen as well. So we have a bunch of announcements that literally just came out about Sidecar extensions. So the way to think about Sidecar extensions is, if you're familiar with App Service and you remember Windows App Service, we had something there called site extensions that let you add some extensibility to the platform, right? So you could bring your own random piece of code that would then run in the SCM site and do magical things for your app. We didn't have an equivalent for that on Linux. So the first thing that we released was the ability to run sidecars with your app. And I'm going to switch over to an app that I have here. And then let's browse over to, so this is a Docker app. And if I go to the deployment center, I can see that I have my main container, which is where my app is running. And then I can go add another custom container that will run as a sidecar. And this is great, but I need to provide all of the information about the custom Docker container that I'm going to be running. And this means that I'm writing either a custom Docker container, or I'm grabbing something from Docker Hub or somewhere else where there's like already a component that I can use and just basically go and configure it, add it to my app. I need to add a bunch of like environment variable, volume mounts if I want to do that. So this is the super flexible, do anything solution. But we know that people also like the easy path. So that's basically what the Sidecar extensions is doing, right? So this is giving you a curated list of extensions that with refresh my browser just for good luck. But then even if I don't get it to work here, you can click on the blog and you'll see the example of the UI down here. So this is telling you what this should look like. So hopefully this loads. If not, it looks like I didn't pay the tribute to the demo gods today. So let's do this. Let's switch over to you, Jeff, and then we'll come back to this demo later on if I get the time to do it. So yeah, Jeff, today we're in the age of AI, and everybody needs to do stuff with AI, and it gets complicated pretty fast, right? So you have something about using some of the new features in SQL with App Service to make that easier and simplify, right?
Yeah, exactly. So today I'm going to be talking about how you can use your existing .NET Blazor apps, which are hosted on App Service, and you can take advantage of this recent feature that Azure SQL announced back in November, where they're supporting a native vector, or they have native vector support for Azure SQL. So this allows you to work with vector data in your Azure SQL database, where you can store vectors, and you have specific vector functions, which can enable you to sort of do the measurements between and calculate vector distances.
So the cool thing about this is that if I already have a web app that is talking to a SQL database, I don't need to redeploy. I don't need to do anything, right? I can just start using this new feature.
Correct. You don't need to redeploy, but there are a few steps that we'll go through to sort of set up your database, because you do need to have it sort of in this vector format, so you can actually do a SQL search against it, nice. Right? And the idea for this is that it enables scenarios like a RAG pattern. So if you're building out a RAG solution and you want to ground the context of the data in your own existing SQL data, you can do so with this new vector support. Also, one thing to note, because everyone's talking about AI agents now, you still need, with AI agents, you still need some way to make sure that it's retrieving the correct data for whatever task it needs to carry out. So, it's still relevant, although it may have been more of a buzzword last year than this year, it's still very much needed. But we'll go ahead and go straight to the demo so we can see how this is used. So here we just have a .NET 9 templated Blazor application, and we've added a chat app that will answer questions about food reviews. So we'll go ahead and ask it, what are the best orange juice brands? And we'll send that request, and it should come back with a list of orange juice brands that were listed in our database, and it does. Then we'll ask it one more question. What do people like about these brands? Send that request, and then it should be, a summary of what people like about those brands. So let's go ahead and take a look at the web app so we can actually see the logs to see how it's actually coming up with those results. So what's happening here is the app is doing a hybrid vector search with the input query, and it's bringing back a few entries from the Azure SQL database that are all related to orange juice. So if you kind of dig through these summaries, you can see it's all talking about some kind of juice. And it's doing this with that hybrid vector search. So it's giving us the most relevant entries that match our query. And if you look on each entry, there is this distance value. Now, that is the calculated distance between your input query and the embeddings that go along with that versus the existing vector data in your Azure SQL database. But keep this in mind. We'll dig into that a little bit more as we take a look at the database so it makes a bit more sense. Okay, so this is the data source that we're using. It's just a sample DB that we've grabbed online that just holds a bunch of food review data. And this particular database already had a vector column in it. So one thing to note is that the vector column was of type nvarchar, and we, for this to work, we need to have it in vector format. And Azure SQL has functions to do the conversion to actually create this next column to be of vector data type. So I can show you the couple of steps needed to do so. And we'll share that announcement as well, because it goes over these steps and how to do them. But you first create the column, and then you cast the vector values into the vector binary column. So, if taking a quick step back, if you're not familiar with any of this stuff, why do we even bother with vectors? What are vector embeddings? And why is it beneficial for search scenarios? So a vector embedding is a numeric representation of data which has relational context and semantic meaning. So you can kind of think of an embedding as a way to create a point on a map where similar items or words are closer together than other ones. So if you have, say, king, queen, joker, ace, like these are all playing card values. They would be closer on a map than maybe a group of colors like green, yellow, blue, black. So the distance between king and queen would be a lot shorter than, say, green, blue, red, or yellow. Right. And as you can imagine, that's really beneficial for search scenarios because it can capture that context and the meaning of the queries, and you can measure that actual distance between them. So back in the logs, when we saw that distance number, that's what it was. They were all close to 1, and that meant that they're more relevant than if they were close to 0, that would mean that they're less relevant of a search result.
Right. So in this scenario, if I'm modernizing an existing application, I have tables in my database that have a ton of data, which is what I want to use for grounding, right? That's the data that I trust. And I'm going to go through the process of generating the vectors, which are basically putting all of that stuff in the map, so then I can calculate the distance.
Yeah, exactly. Yeah, exactly. And we can actually, if we dig into the code a little bit, we'll go through where that vector search is actually happening. So, oh, yeah, it's showing up. Okay, just quick code review. We have the chat.razor file that we've added, which holds all of our chat app content. We're bringing in the message, binding it, and then on request, it goes to our semantic kernel client, where we have our Azure OpenAI chat completion service set up right here. And then our actual message, first, because we are using a Azure SQL query, it goes through a SQL parameter for security, and then we are passing it to our hybrid search query, which happens here. You can see the user message is sent as a parameter along with the model to a stored procedure. So this was a step in setting up your database that I didn't show earlier. But what it does is it takes in your text query and your model, and then it makes a call to your deployed OpenAI model. And here we're using the text embedding model, and it generates those embeddings that will then be compared to the embeddings that are in your SQL DB. So
in this case, the user message is the chat question, right? Like what is the favorite, what is the best orange juice or whatever that was. And then, so it's going to OpenAI, it's generating the numerical representation. And then now I'm going to go compare those to the ones that I have stored in the database.
Yeah, exactly. And as we talk about the distance, we can actually take a look at the stored procedure. I do have the step here to create it, so you can kind of see the inner workings of it, and I've taken out the secrets here. But when you create the procedure, you can see it brings in your text, and then you have to build that URL string, which is your endpoint for your OpenAI model, and then it does a post request. This is where it takes your API key for that specific model. And then the output eventually becomes a vectorized data representation of your embedding. So that's what then, if we go back to the code, gets added here to this variable E, and then it gets calculated in the vector distance function, which is a function that Azure SQL created that we can use to actually compare how far away one vector is from another. So as you mentioned in that comparison, this one in particular is using cosine, which is the measure used to determine how similar two vectors are. And if you kind of think of the spots on the map, again, king and queen are going to be close to 1 in that measurement, and then the other one is going to be 0 if it's something that's just not related.
Right.
Or closer to 0, I should say. So that's where the vector distance is calculated. Now, the hybrid part of the hybrid search query is the rest of the SQL filters that you see here. So we're just selecting the top 5 values where we want the score to be higher than 4, and we want to order the entries by distance, and that's what you saw in the logs earlier. So it's just a way of getting the most accurate search results.
So, and then that basically gets me back to the answer which we got, which was grounded on the data that we had on the database.
Yeah, exactly. Yeah.
Okay.
Go back.
And then
Yeah.
for folks
So
want
that
to
outputs
start
all
with
of
the
this.
phone, you have a guide to do all of this with best practices, right? That's
Yeah, correct. So this is the doc, which will share all of the links. But the doc also includes all of the steps to set this up with managed identity as well, because you want to make sure that you're, of course, when you're dealing with data, you want it to be as secure as possible. So these steps are outlined in this doc, along with the steps to really build out the exact app that I'm showing you. So this is on our Learn docs. We also have a coinciding Azure sample, which I will also share. And once you have your OpenAI resources created and your SQL database all set up, then you can just clone this app and enter your info and get it running.
Awesome. This is really exciting. But what happens if I'm not a .NET developer? App Service supports Python, Node, Java. So I guess, do we have any solution for anything that is not .NET?
Yes.
Yeah. Sorry, go ahead, Denver.
I'm saying, yeah, we do. But you go ahead, Jeff.
That's the
Yeah.
point of going into Denver's demo.
Got it. Yeah. Okay. Yeah. I'll pass it over to Denver.
Thanks, Jeff.
Thanks.
All right, let me get mine on the stage here. There we go. That's me. Okay. So like Byron was saying, you do have other options other than just .NET, and hopefully this is big enough everybody can see it. This sample is using Spring Boot, so Java SE stack on app service, although you can use really any stack. This is just one that we have up and running for Java. It lives in Azure samples, so it's available for you to take a look at if you want to. And even more so than that, this is much more of a sort of, let's call it a quick start sample rather than the more in-depth one that Jeff showed us. But this is really, really easy to get started with because it has all of these moving parts, your app service, your optional database. In this case, it defaults to an in-memory database, but if you want to add that, you can. Azure Monitor, Managed Identity, OpenAI. But using AZD, it's really just a 2-command procedure to get this exact app up and running in app service. All you have to do is initialize it and then run AZD up, and it should deploy everything automatically for you. It can take a little bit of time, so I'm not going to go through the total deployment of it. And there is a blog post that walks you through exactly what happens at every step. But this AZD template makes it as easy as possible for you to just get started with app service, Java, and OpenAI all at the same time here. And again, optionally, if you want to use a database or not. So if we want to see the app running, it looks like this. This is your typical Spring Boot pet clinic, and it's the sort of canonical app for Spring Boot demos. But this one's been modified, and it includes a little chat window here. And again, being a quick start, this doesn't really do quite as exciting of AI stuff maybe as Jeff's demo, but you can still ask it questions. You can still talk to it, and it'll still give you an AI result to your chats in this case. And
I think the key thing here is not about how great code writers we are for the specific scenarios, but how do you get started with an app on app service, doing all of the right things to make sure that is secure, best practices, yada yada yada, so that then you can go and focus on the AI part of it, which is the thing that you're probably going to be doing with your existing code base, right? How do you sprinkle a little bit of AI on it to start adding those features without having to completely re-architect the application?
Exactly. Yeah, and the template included and the code included too. If we want to do a quick look at the code here, this should work. I mean, realistically, no matter how you want to deploy this thing, it all uses managed identity. It sets up these environment variables for you. So no matter what these things are called or what you decide to name them, it does still work. And in this case, we're using WebSockets and this OpenAI client to do all of these WebSocket-based chat messages. But again, this is really just meant to be a template that you can take, modify, upgrade. And if we want to see it in app service itself, all of this stuff is created by AZD whenever we actually deploy it. So these things may be named sometimes funny things with these random identifiers on the end, but that's just so we don't have a naming collision.
Yep. Cool. So I think the demo gods have forgiven me, so I can go back to my thing. Is that all for you, Denver? Do you want to wrap up, or?
Oh, I'm good to go. I think that's it. I'll keep mine short and sweet this time.
Awesome.
There's a blog post for it, and there is the Azure samples and the AZD for it if you want to play around with it, but we'll include all those on the accompanying post to this.
Cool. So I got the UI back, and I think what I was going to show is you saw the custom container, which basically is open, so you can add whatever you want. You can craft your own container that's doing, basically whatever you want, or you can grab something off the shelf. But we also have the Sidecar extensions, which is a curated list where we're adding components here that basically simplify the setup, right? So, for example, you can do Datadog through a custom container Sidecar, or you can just come here and provide the Datadog specific configuration, and you're off and running. You don't even need to know what the Datadog container is. Or if we want to kind of like keep it in the AI stuff, we also have the SLMs that run on app service. So this is the 5.4 model. If you want to get started, we also have a quick start, and this walks you through everything. It has some sample code so you can build that simple chat experience that is going back and using the SLM running locally on app service. So this is something that is really cool. Like, I know that a lot of when I talk to customers, when they talk about AI, they say, hey, there's like 87 models out there. Which one should I use? And I know that is a hard problem to solve, but I say, start with the cheaper one. And if that one doesn't work, then go to the more expensive ones. And the cheapest one that you're going to find is one that you can run locally in the compute of your app. If you're going to do something like summarization of product reviews or something like that, where it doesn't need to be real time, it can run as a background process. This is a great thing to use, because as reviews come in, those could be queued up, get processed synchronously, and your app gets updated, and you pay like next to zero for that, right? It's just the compute that is being consumed on your app. So those are very cool scenarios. The other thing that I wanted to show was, this is a container-based application, right? So I'm pointing my app to pull a specific Docker container, but we also support this for code-based apps. So in this case, this is a code-based app. We go back to Deployment Center. You'll see that I deployed this. Refresh it. You see that I deployed this, from my local machine. I just pushed it up, and the thing that people are going to start seeing is this new container tab for your code-based apps that lets you both add the custom site extension or the custom container, or also pick from that curated list, right? So it doesn't matter if you're deploying code or you're deploying containers. You get access to the extensions functionality, and you can add those things to your app by either grabbing off-the-shelf components or creating your own custom extension if that's what you want to do. And I think that wraps it up for us in App Service. So back to you, John.
All right, that was awesome. I really am happy that you were able to get yours working, because that, like, seeing it in action really kind of made it work for me.
Yep.
I was curious for that, if is there an overlap with Aspire? Can I use Aspire? Because seeing those Sidecar Docker containers, I've got Aspire on the brain. I'm always wondering if that kind of can work with that for local development.
Right. So Aspire right now, as it is opinionated, and it expects you to run everything on ACA, right? If you're doing if you're going down the paved path, right? So all I can say is build is coming up, and there might be some interesting announcements around that and app service.
Very cool. Wow. Well, we didn't get any questions. Those were really clear demos. I loved seeing the move. If your data is in SQL Server, being able to, and your logic, you've got, like a lot of data, because vectors are data, being able to kind of manipulate that at the data level and add your query right down at the query level seems really awesome. So
yeah, and it's something that I keep hearing where, I have customers that come and they're in a panic mode, right? Where they're like they need to add AI to their app and they need to do it like yesterday. And most of the time people go into the re-architect, rewrite mode, which is, 6 months down the road. But the reality is that there's a lot that you can do with your existing app by adding, small components and small changes that have a big impact, right? And I think that's the whole theme of the 3 demos that we were showing, right? Like you can do stuff with the database, and we did very small tweaks to the web app, right? Boom, you got it, right? Or you can go and add a sidecar that has a local SLM if you don't want to be sharing data with a third party, right? Because people are also concerned about that. That way, all of your data stays within your app, and it even runs in disconnected scenarios, right? So I think there's a lot that you can do where you don't need to go and completely re-architect, rewrite the world. You can just do small tweaks and start getting in that AI journey that we're all in.
And your examples showed chat, which is very kind of easy to kind of jump into, and that's a great kind of common language for talking about AI. But as you're talking about that, that's also like you could make your search more intelligent by adding in AI and vector searching, vector similarity, without even any UI changes potentially. Like, right, if I do a product search, I can just rank based on semantic searching or, that sort of thing.
Yeah, or I think I mentioned this during the demo, which is there's also an asynchronous story here, right? So you go to random retailer website and you pick a product, and now you start seeing those summarized customer reviews, right? That they tell you, a lot of customers think that this thing is great, but this thing is bad about this product, or stuff like that. That doesn't need to be real time, right? So you can have a web job that is running behind the scenes, that is talking to the sidecar, that is running the SLM, that is looking at the product reviews and generating and updating those summaries without user interaction, right? So that's another pattern that's interesting, right? It doesn't need to be a human initiated workflow, right? That's the
I love that, seeing that, like you're saying, the offline, the behind the scenes, that like just making the app almost kind of like not a huge in your face thing, but it's like the subtle tweaks, recommended similar products, and like maybe looking at intelligence over orders and saying like, hey, maybe a small sale on this product, or that sort of thing. So
right.
Wow, awesome. Okay, well, that was amazing. Great demos. So and then of course the links and everything for that is shared in the show description if you're watching this later. So thanks a bunch. And I'm looking forward to build. So very cool. All right, well, I guess I'll take you off the screen, and that will wrap us up. So thank you everyone for watching. Thanks for the great questions. A lot of amazing, exciting things there. So again, if you're watching live, all the stuff is in the link for the URList and in the description below. And just remember to like, subscribe, comment, follow us, and catch us in a month for the next Azure Developer Live. And with that, I will say goodbye and have a great rest of your day.